Use the figure to find the length of the missing side in the right triangle. So we're going to apply Pythagorean theorem. Pythagorean theorem allows you to find the missing side of a right triangle if you know at least two of the lengths of the sides. So since we know this length is 6 and this length is 5, then we're going to be able to find that third side by applying the Pythagorean theorem. To apply Pythagorean theorem, what you're going to do is take the length of one of the legs, in this case is 5, and we're going to create a square that comes off of that side. So here's my square, and since I'm creating a square where 5 is the length of one of the sides, then I know this has to be also 5. And if I find the area of this square, it'd be 25. And this side here is length 6. And if I were to create a square that comes off of this side, a square has all sides have the same length. So since this is 6, I know this would also be length 6. And the area of this square would be 36. And then lastly, we're going to take the hypotenuse and create a square that comes off of that side as well. And I don't know what the length of this side is, so I don't know what the area is. But this is how Pythagorean theorem comes into play. The relationship between these three areas would be that these squares that we created here off of the legs, and recall that the legs are the ones that form the 90-degree angle, these areas, when you add them together, will be equal to this area. So if I take 36 and add 25, I get a total of 61. So that's the area of this square. If you know the area of a square and you want the length of one of the sides, you take the area of the square, you find its square root. So if I do the square root of 61 and I use my calculator to approximate it, we get 61. The square root of that would be, I'm going to round it to the nearest tenth, so the first decimal value. So it'd be 7 and 8 tenths. So the approximate value would be 7 and 8 tenths. And again, this is the approximate value of the square root of 61. So this 7 and 8 tenths, that's the approximate length of this side.